And we have some things I highlighted here already. We are going to be highlighting some things here. We've got a sequence is any list of numbers in a certain order. The order matters. Here's the one that you saw before. A term in a sequence is one of the numbers. So we would say this one is term 1, the second one is term 2, the 2 is term 3, the 3 is term 4, and we list our terms that way. And the notation that we're going to use for our terms is we're going to have a t with a little 1 to be term 1, a t with a little 2 to be term 2, t with a little 3 to be term 3. And sometimes this is confusing for students because term 3 has both a letter and a number. Two things to say one thing. I hope you're going to be okay that there's two things. Like if I want to say term 5, I have to use the T for the term and 5 for the, but it still means just one thing. That's just term 5. So this one would be term 4, term 5. I would label this one as term 6. Now the first sequence that we're going to look at is one we saw in our pattern was an arithmetic sequence, where you're always adding or subtracting the same thing to get the next one. And the value that you add or subtract by is called the common difference. So we're going to highlight that as well. And so they have one here. You see each of these numbers are going up by 3. This is on page 3. Oh, the top part? Yeah. So then I just noticed that as we're talking, right? So you can't highlight that part. But you can start with the arithmetic sequence and the common difference. Highlight those. And they do have this first example where we're going up by 3s. Now there are dots at the end. And those dots at the end mean that this keeps on going forever. So we would call this an infinite arithmetic sequence. Anybody remember how I found the formula? Any guesses what the formula would be for this one? 3n plus 1. And we're going to find out that we're going to write the formula now on this side by putting a t with a little n. Because if I want to find, say, 1, 2, 3, 4, okay, it's pretty obvious that term 5 is 16, because I just counted, and it was listed already. Well, we're going to check, can I use the formula to find term 5? If I wanted to use the formula, and I wanted to find term 5, do you see that I'm replacing the n with a 5? So I would need to, in the formula, replace this n with a 5 as well, and sure enough, I get 16. Perfect. And if you plotted everything on the graph, it would make a straight line, and this is connected to something you did in grade 10 math, right? We already talked about our formula being 3n plus 1. Can you see that this is very similar in form to y equals mx plus b? But instead of y, we have a term. Instead of x, we have n. But it still makes a nice straight line. And you might notice that if you measure the distance horizontally and vertically from one point to the next, we go over 1 and up 3, and rise over run is like a slope. So we're going to find out that arithmetic sequences follow a lot of things that we noticed with lines. And the slope of the line also happens to be the common difference. I don't know if you have these ones. No, they're not in it. We're going to go to example 1. And example 1 is really straightforward. If you had an increasing arithmetic sequence, you could start with any number you wanted. Anybody have a favorite number? 7. Oh, great number. And then you could decide to add, because you want it to be increasing, so we want the numbers to be getting bigger, you could add anything you want. So if I added 2, my next number would be 9, then 11, then 13, then 15, then 17, and it would keep on going. We could say that in this case, our common difference is 2, because we're going up by 2's each time. And for B, if I wanted to make something decreasing, somebody else's favorite number? 3. And then I could go down by the same amount every single time. How much am I going down by?
4.
I'm going down by 4. So here, we would say our common difference is negative 4. So when it's decreasing, we would say that it goes down by 4. When it's increasing, it goes up. So what's going to happen in our, for our notes and using this book, you're writing your answers in the space beside. We will be doing this question off to the side and leaving the example that the textbook has written. You can read those on your own if you like. But this is all the work you would have to show for a question like this. And then after I've done a question, what I'm going to do is I'm going to write down questions you could do for homework or for practice. So what we're going to do is we're going to turn to page 8. And on page 8, circle question 4, circle question 5, and circle question 7. The reason we circle them is later when you go home, you're going to go to your homework, and if there's one that's circled that you haven't done yet, then that's telling you should do that before tomorrow. Okay? So these are the questions that we're going to do for practice. And what's often going to happen in class is sometimes I'm going to do a couple of examples and then actually give you time in class to try some of them so that you can ask questions, and therefore we're not moving too far ahead before you've tried some on your own. Usually the time that I give you in class to try them will not be enough time to finish them. So you do have some homework that you will need to do at home. And the expectation is that you always have that done for the next class so that you're able to understand the next class as best as possible. It's also really nice that this class is right after lunch, so you can come early if you had anything on the questions that you're like, I didn't get this one. You can come early, ask those questions, make sure you're on the right track and ready to go for the next day.